Limits is one of those topics that you might need to watch the videos a couple of times just to get the basic understanding of it. Hopefully with this video you're going to get enough strategies to understand the basics on how to solve limits. I am going to focus more on our current curriculum, which doesn't require too much algebraic manipulation, so we are dealing with some basics limits for now. So the definition of a limit is you trying to look at where your function goes when you pick a specific input. Now it might seem a bit silly because you're thinking, well, I can just substitute the value. It's not the point of substitution. We want to see what happens as you can get very close to the number, because soon you'll see examples where you can't actually substitute the numbers in. The numbers will actually give you an error, for example, or you're substituting infinity and you can't substitute infinity. So we want to look at what happens when your function gets very close to a value, and that's called limits. And limits have many uses, especially in the start of calculus. So this is a bit of a worded definition. You can read it on your own, but I'm going to explain it through this diagram taken from Calc Workshop. So the way we read this, and this is the limit notation, is that we say the limit as x approaches a, so it gets very close to a, but it's not equal to. The limit of the function as x approaches a is equal to L. So as I'm bringing in numbers very close to a inside my function gets very close to a specific number. Now, the limit might not necessarily exist. If your function goes up to infinity or negative infinity, that means there is no limit. Your function doesn't approach a certain value, because it just goes on and on. But sometimes it does approach a value, and that could be any real number, including 0, obviously. So any value, any real value. But if it goes to infinity or negative infinity, or you get an undefined function, then you'd say that the limit does not exist. Now, there are certain strategies to find limits, and this is using a numerical method. So you could do a trial and error by creating like a table of value. So you can get your table of value here, and let's say you want the limit as x approaches 1. So you're going to put 1 here, and what you're going to do is come very close to 1 from both sides of the number line. So you're going to be like 0.5, 0.7, 0.9. You're going to get very close to 1, and also you're going to get very close to 1 from this side. So 1.1, for example, 1. You can even go 1.15, 1.6, up to you. So as close as you can get, and you can look at what values you'll get here. And maybe you'll get an undefined value here, but you can see what values you'll get close to, and the closer you are to 1, the better limit you can see. So that's one way. Another way is to directly substitute. Sometimes, if it's possible, you can substitute in. Just be careful not to substitute in 0, and you'll, like, if you have this, you can't just substitute in 0, so it's you can just substitute any value in. You also can't substitute infinity, so you are restricted with this method. Another technique is to simplify. So try to simplify your expression as much as possible. You can simplify and then substitute, simplify and then trial and error, up to you. And sometimes the simplification can help you decide what the limit is. So before we start, let's look at it graphically. So if I have this function, this 1 over x, and as you notice, what happens is when x approaches infinity, positive infinity, your function is getting very close to 0. So it's the y value is getting lower and lower, and it's getting very close to 0, but it's not actually touching 0. So we can say that if x is equal to 0, then 1 over, or if when x is equal to infinity, then 1 over x is equal to 0. The whole statement that I just said is wrong, because you can't just substitute infinity and it can't be equal to 0. We say that the limit as x goes to infinity of 1 over x is 0. And you can see it from the graph. You can test it out by substituting really big numbers here, and you can see that your function will tend to 0. Same thing with a negative infinity. As you go to a negative infinity, 1 over those big negative numbers will give you a 0. So that's nice. But what happens when x approaches 0? If you see in this example, we have, if I'm taking x coming from the positive side, so all the positive, and then I'm approaching 0, my function is going all the way up to positive infinity. But if I'm coming from the negative side and I'm approaching x equals to 0, so x is getting very close to 0 from the negative side, my function is going to negative infinity. So we have a disagreement here based on what the limit is. So this is where we come to something called the left and the right limit. So this was the right limit when I approached it from here, and this was the left limit when I approached it from here. So a limit can only exist, so this limit can only exist if the right and left limit are exactly the same, which means the limit as x approaches to 0 does not exist because they're not matching. The limit as x approaches 0 from a positive side does exist, and from the negative side it does exist, but as x approaches 0 only, it does not exist. So what we call the left and right limit. Now, this is a very simple example, and I'm going to use a couple of strategies to explain the left and right limit. I'm also going to use the strategies mentioned in the beginning. So I could use a trial and error using the table of values, and I'm going to see that the limit as my function approaches, and I'm looking at as x approaches 1, this function is undefined at, technically undefined at x1, but we're going to show how simplification can make us avoid that. So what happens at x approaches to 1, through trial and error, you're going to notice that the limit will be equal to 2. Another thing to note is if we're going to use the second strategy, which is substitution. Now, if I substitute directly, I'm going to get an error. Therefore, I can't do it. So I'll end up dividing by 0 here. Let's use the third strategy, which is simplification. Might take a while, but you should have this trick up your sleeve, which is noticing that the numerator is a difference of 2 squares. So I can write this as x minus 1, x plus 1, divided by x minus 1. These two will cancel out. I end up with x plus 1, which is why I can now substitute 1 in there. So the limit as x approaches 1 of f of x, or more specifically after simplification of x plus 1, is equal to 2. I can now directly substitute after simplification. So I can see that it's 2. So hopefully you've seen now the techniques. But what I want to emphasize is the left and right limits, because they might expect you to do that. So what I'm going to do is take the limit as x approaches 1 from the negative side, and that's coming from here. So this is when you have the table of values. You can look at the table of values, you can look at your graph, and this is you looking at the values on this side and seeing what happens. And hopefully you would notice that x would approach 2. And then taking the limit as x approaches from the positive side, and that would also be 2. Now that I have the left and the right limits being exactly the same, I can therefore say that the limit as x approaches 1 of f of x is 2. Now I picked a simple example just to show you the many different techniques of using trial and error, using the graph, using substitution, using simplification, and also just confirming it using what we call the left and right limit. So the limit of a function exists as x approaches a real value a if and only if the right limit and the left limit are equal to each other. So that's what it means. So if they are the same, then we write that the limit as x approaches a of f of x is equal to L. And you can try this out with different examples. Try to see if the question tells you to find it graphically, then this is you using the graph, noticing how at this point what is the y value. And you can also use the numerical method as mentioned before, but make sure that you do look at the left and right limits, because sometimes if they don't coincide, like this example, then the limit does not exist. So you have to be aware of these facts.